Okay, so we have covered quite a lot of ground with the alkenes as well, and we are almost there to finish the entire series for this as well. Now, one of the topics that we are doing right now is something that we did with alkenes as well, and that's isomerism. And so, if we were to look at the same general definition, and that says isomerisms are molecules with the same general formula, or have I got that right? Same molecular formula, and or same molecular formula but different structural formula, right? This is what we studied. And if we were to talk about butane, so that means like C₄H₈. This is alkanes, by the way. Okay, so if I draw the structures for this is I hate the time it takes to draw out these hydrogens. Yeah, so this is C₄H₈. And if I were to write, or if I were to draw this in a different manner, this is a straight chain. And the isomer for this is going to look something like this. Yeah. This is your branch chain isomer for this. So this is butane, and this is methyl propane. Okay, so these two molecules are what? These two molecules are isomers. But we're talking about alkanes now. Let's dive into alkenes. Now for alkenes, if we take the same molecule, let's say we talk about butene, and we talk about, now you need to know that in alkenes, because in alkanes we only had single bonds, so we had the only straight chain isomers and the branch chain isomers. But alkenes, we have the double bond as well. So there is an aspect of positional isomerism which you won't study in O levels right now. This is more of a part of A levels. But the isomers is going to be like in two different aspects. So one is going to be the straight chain again, and let's take butene, which is C₄H₈, and let me draw the structure. You can have a double bond here, and again added one more hydrogen that should not be there, so let me just erase that. Yeah. Okay, so this is 1 2 3 and 4. This is 1 2 3, and this is 4, and this is 1 2 3 and 4. Right, so this is butene. Okay, but if we were to talk about the isomer for this, which is the isomer that exists as, you can say, the straight chain one, but that is more related with the position of the double bond. So if I were to draw it like this, and I think I also explained this in one of the previous videos. So this is 1 2 3 and 4. This is 1 2 3 and this is 4. This is 1 2 3 and this is 4. And this is 1 2 3 and this is 1 2 3 4. Okay. So here now what I told you guys, we start counting from the place where the carbon where the double bond is closest to the carbon. Okay, so here the double bond is closest to this carbon. So start counting from here. So this is 1, this is 2, this is 3, and this is 4. So we know that the double bond is at the first carbon. So this is going to be called but1ene, right? And here, because there are 4 carbons, and if I were to count from here, so this is 1, 2, 3, and 4. And if I were to count from here, so this is 1, 2, 3, and 4. So from both places, the double bond is on the second carbon. So this is simple. This is going to be called but2ene. Right? Now these two molecules are isomers of each other. And this is something that we call as positional isomerism, which again, you won't be asked to name positional isomerism or explain that, but this is at your syllabus level, we call this straight chain isomers. Okay, so this is one thing. Now, we talked about the straight chain, but we do know that there exists one more form for this. So let's draw butane first. This is 1, 2, 3, and 4. Which is 1, 2, 3, and 4. This is 1, 2, 3, and 4. And this is 1, 2, 3, and 4. So this is a butene molecule, and this is a straight chain butene molecule. And by the way, this is but1ene. Okay, you should know that. And this is a straight chain one. Now the other form that exists, that is the branch chain. So what do we do in that one? We basically break the chain. So if we had, like in this one, we had 4 carbons in a straight chain. So we'll break this chain in a way that the main chain remains of 3 carbon. So if I can just draw it like this, right? So the main chain remains of 3 carbon, and I can either have the double bond here or here. It doesn't matter. Why? Because when we have like 3 carbons, so if I place it here, I'm going to count it from here. So it will be 1, 2, 3. And if I place a double bond here and I count from here, so this is 1, 2, and 3. So at both places, because it exists on the first carbon, so we don't mind where we put it. Okay. So this is one thing. Now, sorry. Okay. So this is, now we can say 3 carbon chain, and we can place the 4th carbon here, right? Or we can even place it at the bottom. It doesn't make any difference. So now it becomes, this is 1, 2, 3, and 4. This is 1, 2, 3, and 4. Okay, yeah. 1, 2, 3, and this is 4. This is 1, 2, 3, and 4. And you have 1, 2, 3, and 4. So this is your branch chain isomer, right? Yeah. And if we were to count this, we've got 3 hydrogens. With this carbon, you've got 1, 2, 3. That makes it 6, 7, 8, 9. Oh, it's 9. I think I've placed one at a place that should not be there. So let me just check. So you've got 1, 2, 3, and 4. You've got 1, 2. Okay, yeah. See how much I mess up these carbons, hydrogen.